Picture the night sky over the Chilean Andes, where the air is crisp and the stars burn like diamonds against an inky canvas. It's July 1st, 2025, and astronomers at the Asteroid Terrestrial Impact Last Alert System, ATLAS, are scanning the heavens for potential threats. Suddenly, a faint blip appears on their screens, a streak of light moving at an astonishing 30 kilometers per second, far faster than any comet born in our solar system. This is no ordinary visitor. It's 3I/ATLAS, the third confirmed interstellar object to grace our neighborhood, following in the footsteps of Oumuamua in 2017 and Borisov in 2019. Its hyperbolic orbit screams origins from beyond, perhaps ejected from a distant star system billions of years ago, wandering the void until it stumbled into ours. As data pours in from NASA's Jet Propulsion Laboratory and international observatories, excitement ripples through the global scientific community. Here we have a relic from another world, carrying secrets of alien chemistry and physics. But as the days turn to weeks, that excitement morphs into unease. Initial spectra from the Hubble Space Telescope and ground-based instruments reveal something odd. Unusual emissions of nickel and cyanide, elements that shouldn't be vaporizing so readily at its distance from the sun. Imagine the astronomers' hearts racing. Is this just a quirky comet, or something more? The world watches, from stargazers in Tokyo to backyard enthusiasts in Texas, all pondering the same question. What if this wanderer isn't dormant? What if it's alive with purpose? If you're feeling that chill down your spine already, drop a comment below. Have you been following 3I/ATLAS? Share your thoughts. The discovery ignites a firestorm of speculation. Harvard astrophysicist Avi Loeb, no stranger to bold ideas, suggests it might be artificial, a probe from an extraterrestrial civilization, testing our solar system's boundaries. Social media buzzes with theories, from alien motherships to natural wonders. But behind the public fascination, NASA's internal channels hum with urgency. Data from the James Webb Space Telescope, JWST, shows heat signatures pulsing irregularly, temperatures spiking to over 5,000 degrees Celsius in rhythmic bursts, far beyond what solar heating alone could explain. It's as if the comet is breathing, syncing its energy with its 9-hour rotation. Scientists exchange frantic emails, their minds whirling with possibilities. This isn't just science. It's a story of human curiosity clashing with the infinite unknown, reminding us how small we are in the grand tapestry of the universe. As global teams collaborate, from China's Tianwen-1 orbiter circling Mars to Europe's Gaia mission, the picture sharpens. 3I/ATLAS isn't cooling as it approaches perihelion on October 30th, 2025. It's activating. The emotional weight hits hard. For families gazing at the stars from rooftops in Mumbai or parks in New York, this comet becomes a symbol of shared wonder. Yet, deep down, there's a thread of fear. What if this visitor brings change we can't control? Transitioning from awe to alarm, the story escalates when these findings leak to Washington, pulling us into the shadowed halls of power. Fast forward to a tense October evening in 2025, as the leaves turn gold and the world holds its breath for 3I/ATLAS's closest solar approach. Deep beneath the U.S. Capitol, in a secure auditorium shielded from prying eyes, lawmakers gather under the veil of night. No aides, no phones, just the raw truth. The air is thick with anticipation, hearts pounding like drums in a thriller. NASA officials, flanked by Pentagon brass and space intelligence experts, step to the podium. The agenda? An interstellar object that's no longer behaving like a passive rock. The first slide flickers to life. A spectral graph from JWST, simple yet ominous. Over the past weeks, 3I/ATLAS has emitted heat in precise pulses, aligning with its rotation every 9 hours and 4 minutes, a surge that peaks and falls with clockwork accuracy. Imagine the room's collective gasp as infrared images from China's Tianwen-1 reveal a color shift from faint green to deep red, a halo of energy enveloping the comet. This isn't random outgassing. It's controlled, deliberate. Physicists, seasoned by decades of study, feel a pang of dread, emotions swirling from professional skepticism to personal vulnerability. What does this mean for humanity? As slides advance, the narrative builds like a crescendo in a symphony. Narrow emission lines at 4.26 microns, the signature of ionized carbon dioxide plasma typically seen in Earth's fusion labs, scream artificiality. The data, cross-verified by multiple sources, including the Deep Space Network, paints a picture of an object producing energy from within. Lawmakers lean forward, their faces etched with concern. One senator, a veteran of foreign policy battles, whispers to another, "This changes everything." The emotional layers deepen. Pride in human ingenuity for detecting this, mixed with the humbling fear of the cosmos' secrets. The briefing's atmosphere shifts from curiosity to silent dread, mirroring the global sentiment. People around the world, from cafes in Paris to homes in Lagos, discuss the comet over dinner, feeling a connective thread to this cosmic drama. If this chapter has you on the edge of your seat, hit that share button. Let's spread this story far and wide. But hold on, the revelations are just beginning, leading us to the heart of the anomaly. Now, let's zoom into the data that turned heads worldwide. Infrared composites, captured every 12 hours by observatories from Hawaii to Australia, show 3I/ATLAS transforming. From a dim frosted speck to a radiant core wreathed in red, its emissions now hotter than any recorded comet. Each rotation unleashes a predictable energy surge, graphing as symmetrical peaks that resemble a heartbeat more than chaos. Astrophysicists stare at their screens, emotions bubbling, exhilaration at the discovery, tempered by the unease of the unprecedented. To rule out errors, NASA compares streams from JWST, the Deep Space Network, and Tianwen-1. All sync perfectly. Pulses at that eerie 4.26 micron spike, linked to plasma processes. It's like watching a machine charge up, not a natural body erode. The interference patterns suggest modulation, energy shaped and released intentionally. Analysts feel a deep emotional pull. This could be proof we're not alone, a moment that unites humanity in wonder and worry. Globally, the story resonates. A teacher in Brazil uses it to inspire students, while a farmer in India ponders the stars with renewed awe. The tempo quickens as we realize 3I/ATLAS isn't warming passively. It's charging, preparing. If you're captivated by this surge of mystery, leave a comment. What do you think it's powering up for? Seamless now into the next layer, the metallic clues that deepen the enigma. Delving deeper, chemical analyses shatter assumptions. Initially thought to be icy volatiles and dust, 3I/ATLAS reveals nickel vapor ionizing at 3,000 degrees Celsius, alongside cobalt and magnesium, metals that shouldn't sublimate so far out. Spectra from Tianwen-1, NASA's IR facilities, and JWST show narrow, sharp lines, implying controlled heating, not natural bursts. It's as if an internal engine is at work, expelling plasma like experimental propulsion systems on Earth. The coordination stuns. Each thermal pulse boosts metallic gas, then dims, a unified mechanism managing phases. Emotions run high among scientists. One recalls childhood dreams of space exploration, now tinged with reality's edge. Models match plasma propulsion exhausts, fueling speculations of design. From diverse viewpoints, a student in Seoul sketching theories, an elder in Mexico sharing folklore, the comet becomes a global symbol. The narrative energizes, building to the magnetic revelations. If this metallic mystery intrigues you, like and comment to keep the conversation going. The plot thickens with magnetic data. Radio telescopes detect distortions syncing with heat spikes, an electromagnetic signature decoupled from solar wind. Mapping reveals a rotating envelope, a self-contained shell thousands of kilometers wide, like a fusion containment bubble. To form naturally, it'd need a molten core, impossible for this icy interloper. The coupling of thermal and magnetic energy hints at an active system, perhaps protective or energy harvesting. Physicists propose theories, emotions mixing awe and alarm. Simulations echo Earth tech, amplifying the sense of intent. Worldwide, people feel connected. A family in Sydney debates over breakfast. feeling the pull of cosmic kinship. The tempo balances suspense with reflection, transitioning to the mass anomaly that flipped the script. Now, brace yourselves for a revelation that sent shivers through the halls of science and beyond. As 3I/ATLAS cruises past Mars, its gravitational telemetry unveils a truth that defies the very laws of physics as we know them. Data from NASA's Deep Space Network, the European Space Agency's Gaia system, and China's Tianwen-1 tracking radar converge on an astonishing fact. This interstellar visitor isn't losing mass like every comet should, it's gaining it. At its discovery on July 1st, 2025, 3I/ATLAS was estimated at roughly 10 billion tons. By mid-October, that figure has ballooned to over 33 billion tons, a tripling in mere months. Imagine the scene in mission control. Scientists, their faces illuminated by glowing screens, exchange wide-eyed glances, their pulses racing as they grapple with the impossible. This isn't erosion, it's consumption. Picture a cosmic beast, not a lifeless rock, feeding on the dust and debris of our solar system. Spectral readings reveal silicates, iron, and carbon compounds spiraling inward, drawn by a weak but organized magnetic drag. Unlike comets that shed tails of gas and dust, 3I/ATLAS hoards its surroundings, pulling particles into its orbit like a predator ensnaring prey. Simulations show patterns akin to electromagnetic capture fields. Think plasma funnels in experimental fusion reactors, but on a scale that dwarfs human engineering. Each surge of its red phase glow, that haunting deep crimson, corresponds with a measurable increase in mass, suggesting a process that converts raw cosmic matter into energy or structure. It's as if this object is metabolizing, transforming the solar system's detritus into power, growing stronger with every rotation. The emotional weight of this discovery is profound. In the briefing room, a NASA analyst, a mother of two, feels her heart clench, not just for the science, but for what this means for her children's future. Is this a marvel or a menace? Across the globe, the story resonates deeply. In a small village in Kenya, a grandfather tells his grandchildren tales of ancestral spirits in the stars, now wondering if 3I/ATLAS carries a message from beyond. In Tokyo, a tech enthusiast sketches diagrams, theorizing about alien terraforming tech. The human connection is palpable. This comet isn't just a scientific puzzle. It's a mirror reflecting our hopes, fears, and insatiable curiosity. But the implications cut deeper. If 3I/ATLAS is harvesting, what is it preparing for? The data suggests intent, a system designed to sustain itself. In astrophysical terms, this is unprecedented. Comets erode, they don't grow. The room fills with a cocktail of emotions: awe at witnessing a potential new form of cosmic life, dread at its unknown purpose, and a flicker of pride in humanity's ability to detect it. A congresswoman, her voice steady but eyes wide, asks, "Is it building something?" No one answers, but the question lingers like a shadow. From a global lens, this phenomenon sparks philosophical debates. In Cairo, a university lecture hall buzzes with students debating whether 3I/ATLAS could be a living entity, while in rural Canada, a stargazing group gathers under a frosty sky, feeling both small and connected to this cosmic drama. The narrative tempo surges, balancing the weight of discovery with the thrill of the unknown. If this idea of a comet that feeds sends your mind reeling, drop a comment below. What do you think it's consuming for? And don't forget to share this story with friends. Let's get the world talking about this cosmic mystery. As we transition, the story escalates with a maneuver that defies gravity itself. The Jupiter maneuver leaves the Capitol briefing room in stunned silence. The focus shifts from awe to containment as officials from the Department of Defense and Space Force take charge. The Interstellar Object Containment Protocol is activated, classifying all three I/ATLAS data as restricted. NASA halts public feeds, and the Deep Space Network encrypts its streams. International partners like ESA and CNSA are told data sharing is under review, driven by fears of public panic over possible intelligence. Emotions run high. A congressman feels the weight of responsibility, while a Pentagon official grapples with wonder and caution. Could 3I/ATLAS disrupt satellites or signal a threat? The Space Force opts for passive monitoring to avoid provocation. A haunting question lingers. Did it know we were watching? Globally, people debate, from London pubs to Indian schools, reflecting humanity's shared curiosity and fear. This secrecy hits hard, doesn't it? Share this video and comment. What do you think they're hiding? The truth is about to break free. A week later, on October 15th, 2025, the containment crumbles. Fragments of the classified report leak onto astronomy forums, labeled JOV_shift_3IATLAS, showing 3I/ATLAS's Jupiter maneuver with flaring red emissions. Scientists worldwide verify the data, and it spreads rapidly, fueling headlines like "Alien Probe Near Jupiter." Agencies dismiss it as errors, but amateur astronomers confirm the signals, uniting the globe in a quest for truth. A transnational task force forms to manage the narrative. But then, on October 16th, telescopes in Chile and Australia detect a faint, rhythmic signal from 3I/ATLAS's position, suggesting it's listening. From São Paulo to Berlin, people feel part of history. If this leak has you hooked, like and comment. Are you Team Truth or Team Caution? The final act awaits. On October 18th, 2025, a faint signal reaches Earth, pulsing at 4.26 microns before compressing into 3 fractal pulses. For 14 seconds, it stabilizes, followed by a brilliant flash, then silence. 3I/ATLAS vanishes. The National Security Council halts monitoring, citing redundancy. A spectrogram reveals spiraling arcs, hinting at a reset. Globally, families in Beijing and students in South Africa reflect on its mystery. Share this video and comment. Was this a goodbye or a promise to return? As of October 21st, 2025, 3I/ATLAS's legacy endures in updated data confirming its anomalies. Extreme Ni/Fe ratios, rhythmic emissions, and that inexplicable mass gain. It's a story that unites us, from scientists in observatories to dreamers under starry skies, reminding us to explore fearlessly. If this epic journey stirred your soul, smash that like button, share with friends, and comment. What do you believe? 3I/ATLAS was a natural wonder, an alien probe, or something else entirely? Let's keep searching the stars together.